Hello and welcome to this new video in which we are going to talk about descriptive statistics. If you discover our channel for the very first time, don't hesitate to subscribe and activate the notification bell so you don't miss any of the next videos. A like and sharing of this video will also make us happy and allow many other people to discover it. Let's start with basics of statistics. Statistics is the science of collection, presentation, analysis, and reasonable interpretation of data. Statistics presents a rigorous scientific method for gaining insight into data. For example, suppose we measure the weight of 100 patients in a study. With so many measurements, simply looking at the data fails to provide an informative account. However, statistics can give an instant overall picture of data based on graphical presentation or numerical summarization irrespective to the number of data points. Besides data summarization, another important task of statistics is to make inference and predict relations of variables. A taxonomy of statistics. Statistics has two main branches, descriptive and inferential. In descriptive methods we have univariate, bivariate and multivariate statistics. As far as univariate statistics is concerned, what can be done is shape, center, spread and relative position. Bivariate statistics look at things like correlation and regression for prediction purposes. Lastly, we have multiple regression in multivariate statistics. Statistical description of data. Statistics describes a numeric set of data by its center, variability, shape. Statistics describes a categorical set of data by frequency, percentage or proportion of each category. Here are some definitions. Variable, any characteristic of an individual or entity. A variable can take different values for different individuals. Variables can be categorical or quantitative. Nominal, categorical variables with no inherent order or ranking sequence such as names or classes, e.g., gender. Value may be a numerical, but without numerical value, e.g., I, 2, 3. The only operation that can be applied to nominal variables is enumeration. Ordinal, variables with an inherent rank or order, e.g. mild, moderate, severe, can be compared for equality, or greater or less, but not how much greater or less. Interval, values of the variable are ordered as inordinal, and additionally, differences between values are meaningful, however. The scale is not absolutely anchored. Calendar dates and temperatures on the Fahrenheit scale are examples. Addition and subtraction, but not multiplication and division are meaningful operations. Ratio, variables with all properties of interval plus an absolute, non-arbitrary 0 point, e.g. age, weight, temperature, Kelvin. Addition, subtraction, multiplication, and division are all meaningful operations. Distribution of a variable tells us what values the variable takes and how often it takes these values. Unimodal, having a single peak bimodal, having two distinct peaks symmetric, left and right half are mirror images. Frequency distribution. Consider a data set of 26 children of ages 1 to 6 years. Then the frequency distribution of variable age can be tabulated as follows. Cumulative frequency. Cumulative frequency of data that we show you earlier are on the tables. Data presentation. There are two types of statistical presentation of data, graphical and numerical. Graphical presentation. We look for the overall pattern and for striking deviations from that pattern. Overall pattern usually described by shape, center, and spread of the data. An individual value that falls outside the overall pattern is called an outlier. Bar diagram and pie charts are used for categorical variables. Histogram. Stem and leaf and box plot are used for numerical variable. Data presentation categorical variable. Bar diagram lists the categories and presents the percent or count of individuals who fall in each category. Pie chart lists the categories and presents the percent or count of individuals who fall in each category. Numerical variable. Histogram. Overall pattern can be described by its shape, center, and spread. The following age distribution is right skewed. The center lies between 80 to 100. No outliers. Box plot describes the 5-number summary. Numerical presentation. A fundamental concept in summary statistics is that of a central value for a set of observations and the extent to which the central value characterizes the whole set of data. Measures of central value such as the mean or median must be coupled with measures of data dispersion, e.g., average distance from the mean, to indicate how well the central value characterizes the data as a whole. To understand how well a central value characterizes a set of observations, let us consider the following two sets of data: A, 30, 50, 70b, 40, 50, 60. The mean of both two data sets is 50. But the distance of the observations from the mean in dataset A is larger than in the dataset B. Thus, the mean of dataset B is a better representation of the dataset than is the case for set A. Commonly used methods are mean, median, mode, geometric mean, etc. Mean. Summing up all the observation and dividing by number of observations. Mean of 20, 30. 40 is 20 plus 30 plus 40, divided by 3, which is equals 30. Let x1, x2, xn are n observation of a variable x. Then the mean of the variable is x1 plus x2 plus xn divided by n. Median. The middle value in an ordered sequence of observations. That is, to find the median we need to order the dataset and then find the middle value. In case of an even number of observations, the average of the two middlemost values is the median. For example, to find the median of 9, 3, 6, 7, 5, we first sort the data giving 3, 5, 6, 7, 9. Then choose the middle value 6. If the number of observations is even, e.g., 9, 3, 6, 7, 5, 2, then the median is the average of the two middle values from the sorted sequence, in this case. 5 plus 6, 2 equals 5.5. Mode. The value that is observed most frequently. The mode is undefined for sequences in which no observation is repeated. When to use mean or median? The median is less sensitive to outliers, extreme scores, than the mean and thus a better measure than the mean for highly skewed distributions, e.g. family income. For example, mean of 20, 30, 40. And 990 is 20 plus 30 plus 40 plus 990, divided by 4, which is equals 270. The median of these 4 observations is 30 plus 40, divided by 2, which is equals 35. Here 3 observations out of 4 lie between 20 to 40. So, the mean 270 really fails to give a realistic picture of the major part of the data. It is influenced by extreme value 990. Methods of variability measurement. Variability, or dispersion, measures the amount of scatter in a dataset. Commonly used methods: range, variance, standard deviation, interquartile range, coefficient of variation, etc. Range, the difference between the largest and the smallest observation. The range of 10, 5, 2, 100 is 100 to 2 equals 98. It's a crude measure of variability. Methods of variability measurement. Variance. The variance of a set of observations is the average of the squares of the deviations of the observations from their mean. Variance of 5, 7, 3. Mean is 5 plus 7 plus 3, divided by 3, which is equals 5, and the variance is 5 to 5, square plus 3 to 5, square plus 7 to 5, square divided by 3 to 1, which is equals 4. Standard deviation, square root of the variance. The standard deviation of the example is 2. Quartiles. Data can be divided into 4 regions that cover the total range of observed values. Cut points for these regions are known as quartiles. In notations, quartiles of a data is the n plus 1 divided by 4 QTH observation of the data, where Q is the desired quartile and n is the number of observations of data. The first quartile, Q1, is the first 25% of the data. The second quartile, Q2, is between the 25th and 50th percentage points in the data. The upper bound of Q2 is the median. The third quartile, Q3, is the 25% of the data lying between the median and the 75% cut point in the data. Q1 is the median of the first half of the ordered observations, and Q3 is the median of the second half of the ordered observations. In the following example, Q1 equals 15 plus 1 divided by 4 equals fourth observation of the data. The fourth observation is 11. So Q1 is of this data is 11. An example with 15 numbers 3, 6, 7, 1, 1, 1, 3, 2, 2, 3, 0, 4, 0, 4, 4, 5, 0, 5, 2, 6, 1, 6, 8, 8, 0, 9, 4. The first quartile is Q1 equals 11. The second quartile is Q2 equals 40. This is also the median. The third quartile is Q3 equals 61. Interquartile range. Difference between Q3 and Q1. Interquartile range of the previous example is 61 to 40 equals 21. The middle half of the ordered data lie between 40 and 61. Decils and percentiles. Decils. If data is ordered and divided into 10 parts, then cut points are called decils. Percentiles. If data is ordered and divided into 100 parts, then cut points are called percentiles. 25th percentile is the Q1, 50th percentile is the median, Q2, and the 75th percentile of the data is Q3. In notations, percentiles of a data is the n plus 1 divided by 100 PTH observation of the data, where P is the desired percentile and n is the number of observations of data. Coefficient of variation, the standard deviation of data divided by its mean. It is usually expressed in percent. The coefficient of variation is the ratio of standard deviation and mean time 100 and is measured in percentage. 5-number summary. The 5-number summary of a distribution consists of the smallest, minimum, observation, the first quartile, Q1, the median, Q2, the third quartile, and the largest, maximum, observation written in order from smallest to largest. Box plot. A box plot is a graph of the 5-number summary. The central box spans the quartiles. A line within the box marks the median. Lines extending above and below the box mark the smallest and the largest observations, i.e., the range. Outlying samples may be additionally plotted outside the range. That's it for this video, and we hope you find it useful. And if you haven't done so yet, don't hesitate to subscribe and activate the notification bell so you don't miss any of our upcoming videos. A like and sharing of this video will also make us happy and allow many other people to discover it, while knowing that all the efforts we make allow you to improve on a daily basis on statistical models applied to the social sciences. On this we say see you very soon for a new video.